Next section in Chapter 1 will discuss the types of data. We broke down the statistical analysis and what we should be looking for. And we talked about anyway, what we should be looking for when data is taken, the context, who's taking it, how is it being taken, why is it being taken, are the samples voluntary or are they, you know, done mandatorily and picked at random, etc. Things that we have to take a look at. But now we'll take a look at the types of data that we can gather from these populations and samples. Let's talk about a parameter versus a statistic. A parameter is a numerical measurement that describes the population. And the example here is that if 55% of senators are Republicans, the 55% becomes a parameter because it's based on the entire population of senators in the world. Um, Obviously, there are only 50 senators, 100 senators. So it's a lot easier to take a parameter from a small population. Whereas a statistic is a measurement that describes a characteristic of a sample. So, for example, if we take a poll of female athletes and 49% of them say that cheerleading isn't a sport, that's only a statistic because only part of the population of Wallkill Senior High School was actually accounted for. We were only doing female athletes. We weren't doing all students, or we weren't doing all students and teachers, etc. So things we have to take into account. Quantitative versus categorical data, and you've actually done this previously in integrated algebra. It wasn't called categorical, it was called qualitative, and we'll discuss it more. Quantitative data, basically numerical data, you can see the word quantity in there. It consists of numbers and it represents counts or measurements. The example there is the ages of survey respondents. Now, the one thing to keep in mind here is that not all numerical data is, or excuse me, let me take that back. Not all data that has to do with numbers is necessarily quantitative data. It can be categorical data or qualitative data, names and labels. And my example there, not only with political party affiliations, but there's basketball jersey numbers. The numbers there don't represent measurements. You don't give the best player on the team number one unless he wants number one. Basketball jersey numbers are done completely at the liking of the player. I know when I played, I wore number 54. It was just one of my favorite numbers at the time, and really it was because I was being a big dork, and I used to wear goggles instead of my glasses when I played. And there was a player by the name of Horace Grant back in the day, and he wore goggles, so I wore 54 just like he did. Kind of a dorky thing to do, but look who you're dealing with. So discrete data versus continuous data. Discrete data is when the number of possibilities is finite. Now, again, here's another term that you talked about in integrated algebra as freshmen. Finite, it's countable. An example here is the number of baskets that a basketball team scores on any given night. You can count those. You're not going to say, it's 4 and 3/8 baskets. You're not going to do that. It's a whole number. Most of the time, it'll be whole number data when you're doing discrete data. Whereas with continuous data, that could be infinitely possibilities, and the range is on a continuous scale. Now, the key part about the continuous data is that the range covers a whole different mess of values, but there are no gaps in the data. The example there, the amount of milk a cow gives over the course of a year, It could give, it could give 48.2 gallons one day and 36.5 gallons another day. You don't have, and it can be infinitely many numbers. It could be 36.55 and 36.555. Remember that there are infinitely many numbers between each of the numbers on the number line. So we're talking about massive, massive amounts of numbers, which is why we call this continuous data. There's so many different possibilities. Whereas with the number of baskets with the basketball team, there aren't as many possibilities. Like I said, you can't get 3.555 baskets. And again, we've stressed the importance of speaking correctly with statistics, and correct grammar in this case would dictate that anytime we're using discrete data, we use the word fewer, and with continuous data, we use the word less. I'm going to do my best to uphold that. It's actually my first time dealing with that particular type of rule, but we'll do the best we can to get through it together. So levels of measurement, let's talk about all the different ways that we can measure responses. The first is nominal, and that's data that only consists of names, labels, or categories, and you can't really arrange the data in any particular order. An example here would be like if you were doing a survey and it's the answers are yes, no, or undecided. Now, it's not to say that you're counting the number of yeses and counting the number of nos and counting the number of undecideds. No, you're just saying it's either, you're talking about the answers in particular. It's yes, it's no, or it's undecided. You don't want to really put them in order. Ordinal level, data that you can arrange in some sort of order, but when you take the differences between them, and obviously when we talk differences, we're talking subtraction, it doesn't have any meaning. The great example there is course letter grades. Clearly, A is better than B, is better than C, is better than D, is better than F, but you can't really subtract A minus C. It doesn't make any sense per se. There's no really level of meaning with the difference. The interval level is when you can arrange stuff in order and differences have a meaning, but there's no natural 0 point, or there's no way to ever express 0. For example, would be when we're talking about different years. If you were doing a study that did differences in the number of students that are taking AP courses from the year 1990 to the year 2013. There's a difference there of 23 years, and that has a meaning, but there's no year, there is a year 0 per se, but it really doesn't have a meaning because we have a year 0, but we also have like 2000 BC. So really there's been two instances of the year 2000. There's 2000 BC and there's 2000 AD in terms of our calendar years. So it's a little bit more difficult to characterize the differences in terms of interval level. The last one is ratio level, and that's where you have the whole kit and caboodle. You have everything arranged in order. Differences can be found. Ratios can be found, and they have different meaning. And there's absolutely a natural 0 point with ratio level. For example, if you're talking about different distances in a road race and what people ran, or how fast they ran in terms of time and stuff like that, you're going to have a natural 0 point where there's no difference between some people, and you're going to have different levels that you can deal with, and they can all be put into ratio format. And your homework in this section is going to be more questions, basically identifying more data. It's textbook pages 16 to 17, numbers 2 to 32 even.